Okay, so here it says, given that a rectangle has side lengths 4n plus 6 and n minus 3, use an area model to determine the area. I do want to be clear that whenever you take your test or a quiz, I'm not going to give you an area model to prompt you with that. You need to be able to create your own area model, just like I've told you in class since day 1 of starting this new unit. Likewise, with the problems that were later on, I'm not going to give you all of this stuff. You're going to be expected to generate that on your own on a quiz or a test. But anyhow, here it says, given that a rectangle has these side lengths, use an area model to determine the area. So we're going to go ahead and take these values and populate an area model. So I've got 4n and then positive 6. Then I have n and negative 3. And let's calculate the area of this, diagram. So we have 4n times 1n. 4 times 1 is 4. N times n is n squared. 4n times negative 3. 4 times negative 3 is negative 12. And then we have the n. 6 times 1n. 6 times 1 is just 6. And the n. And then we have 6 times negative 3. That is negative 18. So the area of this scenario would be 4n squared. And we have 6n and negative 12n. So that's going to give us negative 6n and negative 18. Okay, let's look at number 2. Here our side lengths are 3k minus 2 and 3k minus 2. So this is actually a square. So 3 times 3 is 9. K times k is k squared. 3k times negative 2 is negative 6k. Negative 2 times 3k is negative 6k. And negative 2 times negative 2 is positive 4. So the area of this certain figure is 9k squared minus 12k plus 4. And I just, added up all my terms inside of the model. Okay, number 3. Here we have a rectangle with side lengths 3n plus 2 and 3n minus 2. Okay, let's go ahead and figure out the total area. 3 times 3 is 9. N times n is n squared. 3n times negative 2. Well, 3 times negative 2 is negative 6. And we have n. Then we have 3n times positive 2, which is 6n, and positive 2 times negative 2, which is negative 4. Combining our like terms, we find that the area is 9n squared plus 0n minus 4, which is technically 9n squared minus 4. I do want to point out that this is called a difference of squares, which is a special pattern for you to recognize. And a difference of squares is when we have one perfect square minus another perfect square. So let's talk about that. 9n squared is technically the same thing as 3 squared times n squared, which is truly the same thing as 3n squared. And then the 4, that's the same thing as 2 squared. Okay, so what we really have here is we've got 3n squared minus 2 squared, which is nice because if you notice this pattern, you can actually whoops, I was going to try to highlight this, but it's not working for me. But when you notice this pattern, you can quickly factor without having to do any true thing. I mean, you're doing some thinking, but you're not actually going through factoring by grouping or anything. Anyhow, let's look at factoring problems. Number 4, it says, given that a rectangle has an area of 5n squared minus 4n minus 12, determine the binomial side lengths through factoring. So here A is 5, B is negative 4, C is negative 12. We want factors of A times C that add to B. So 5 times negative 12 is negative 60. And we want factors of negative 60 that add to negative 4. So we're going to run through our factor tree. We're going to have 1 times negative 60, negative 1 times 60, 2 times negative 30, negative 2 times positive 30. We're going to have 3 times negative 20, okay, and I have found my pair of factors of A times C that add to B. I know that 6 times negative 10 equals negative 60, and likewise 6 plus negative 10 equals negative 4. So we know that 6n plus negative 10n equals negative 4n. And we're going to use this fact to rewrite our b term. Okay, that is the whole key every single time when you're factoring by grouping. This is the process you take. So first you copy down your original problem. And we want to rewrite our b term with what it's equal to. We know that negative 4n is the same thing as 6n plus negative 10n. So we are going to substitute in place of negative 4n, 6n plus negative 10n. From here, we're just going to group our first two terms and group our last two terms. For the first group, we see that our greatest common factor is n. For our last group, we can see that our greatest common factor is negative 2. And I'm saying negative because I see both of these are negative. So I don't know why. Switch to blue. Let me go ahead and write that down first, that negative 2. Okay, so that's going to leave us with 5n plus 6. And notice that these groups here, they are the same. So they are the new GCF between our two terms. I have one term here plus another term there. And those two terms share that common group, 5n plus 6. I like to write it out first to the left. Some of you prefer to write it to the right. Order does not matter. Okay, now here's my answer. I'm done. But moving forward from today, I am going to require that you check your work. Okay, so to check your work, you're going to copy down your answer. And you are going to distribute, so multiply it out. You do not have to use an area model when you're checking your work. So 5n times n is 5n squared. 5n times negative 2 is negative 10n. Next we have positive 6 times n, which is positive 6n. Positive 6 times negative 2 is negative 12. I want to pause and point out that this line of work that I have right here is the exact same thing we had when we rewrote our b term at the very start of this problem. Okay, the only thing that's different is the 6n and the negative 10n have switched locations, but that's no problem. That is completely fine because the community property says that it's fine. Okay, anyhow, so let's go ahead and combine our like terms. We're going to have 5n squared minus 4n minus 12. Okay, so this checks out. Again, so moving forward, this will be a requirement for you when you are factoring. Number 5, here we have a rectangle with an area of 9n squared minus 1. We can see that our a value is 9 and our c value is negative 1, but some of you kind of, pause. You're like, oh my gosh, we don't have the other term. And so I actually gave you guys a hint, and it says, missing a term. Hint, if I were to tell you that I have no money, what number represents that? And so hopefully most of you were like, 0. If Miss LaRue has no money, then she has $0. Okay, so b is 0. We want factors of a times b that add, or not a times b, we want factors of a times c that add to b. So factors of negative 9 that add to 0. I do expect you to run through your little factor tree. Okay, and we can see those factors of a times c that add to b here. So we know that 3 plus negative 3 equals 0, and also 3 times negative 3 equals negative 9. I expect you to also pull in on your variables and rewrite this little addition fact. Okay, and then from here, you're going to go ahead and go through the factoring process. We're going to copy down our original problem. And we're going to replace our b term with what it's equal to. We're going to group our first two terms, and we're going to group our last two terms, and we're going to pull out the greatest common factor between each group. For the first group, the GCF is 3n. For the second group, the greatest common factor is negative 1. And now you should be able to see that your groups are what is now in common. This happens every single time unless you've made a mistake. So I'm going to go ahead and factor out that common group. And when I do, I see that I'm left with 3n plus -1, which is just 3n minus 1. Again, moving forward, I do expect you to check your work. Okay, so we're going to go ahead and copy this problem down, or our answer. And let's multiply it out. 3n times 3n is 9n squared. 3n times -1 is -3n. And then we're going to have 1 times 3n, which is 3n. 1 times -1 is -1. Again, I want to pause and point out that this is the exact same terms. These are the exact same terms we had when we had replaced our b term with what it's equal to. Okay, but moving forward, we've got 9n squared plus 0n minus 1, which is indeed 9n squared minus 1. So that checks out. So we know our answer is a good answer. So let's go ahead and look at number 6. Number 6 says that our rectangle has an area of n squared plus 6n plus 9. So a is 1, b is 6, c is 9. We want factors of a times c that add to b. So let's run through our factor tree, and bingo, we just found those factors. 3 plus 3 equals 6, so 3n plus 3n equals 6n. We use this fact to rewrite our b term. So I'm going to go ahead and copy down the problem. Next, we're going to rewrite the problem with our little fact over there, those factors of a times c that add to b. We're then going to group our first two terms and our last two terms. We're going to pull out the GCF from each group. And here at this point, if your groups are not the same, you have made a mistake. But here, lucky for us, the groups are the same, and that's always going to happen in my classroom. Just know when you move on to Algebra 2, you might have scenarios where they aren't the same, and you might have to use a quadratic formula in order to get those roots or solutions. But anyhow, when I factor out that common group, it leaves me with n plus 3. And notice that I have two quantities that are exactly the same. I have n plus 3 times n plus 3. So when that happens, technically what we have is n plus 3 squared. You guys know that. Anything times itself is itself squared. Now we need to check our work. Okay, so I expect you to copy down your solution. We need to expand that solution. And I do not expect you to use an area model when checking your work. I'm fine with you just distributing. So I'm just kind of going through that motion here. And again, I want to pause and I want to point out that this line of work right here is exactly the same as what we had earlier when we replaced our b term with what it's equal to. So let's go ahead and move forward, combining our like terms. And we are finished. This checks out with what we started with. So that means that this solution is correct.